Section 1.4 Units of Measurement. Many properties of matter are quantitative, that is, they are associated with numbers. When a number represents a measured quantity, the units of that quantity must always be specified. To say that the length of the pencil is 17.5 is meaningless. Expressing the number with its units, 17.5 centimeters, properly signifies the length. The unit for scientific measurements are those of the metric system. The metric system, which was first developed in France during the late 18th century, was used in the system of measurement in most countries throughout the world. The United States has traditionally used the English system, although the use of the metric system is becoming more common. For example, the contents of most canned goods and soft drinks in grocery stores are now given in metric as well as English units, as shown in Figure 1.16. Figure 116, metric units. Metric measurements are increasingly common in the United States, as exemplified by the volume printed on the soda can. Topic 1. SI units. In 1960, an international agreement was reached specifying a particular choice of metric units for use in scientific measurements. These preferred units are called SI units, after the French Système International des Unités. That was French. This system has 7 base units from which other units are derived. Table 1.4 lists these base units and their symbols. Table 1.4, SI base units. The unit of mass is the kilogram. The unit of length is the meter. The unit of time is the second. The unit of temperature is the Kelvin. The amount of substance is the mole. The electric current is the ampere. And the luminous intensity is the candela. Table 1.4 lists these base units and their symbols. In the chapter, we'll consider the base units for length, mass, and temperature. In the metric system, prefixes are used to indicate decimal fractions or multiples of various units. For example, the prefix milli represents a 10 to the 3 fraction of a unit. A milligram is a 10 to the negative 3 gram. A millimeter is 10 to the negative 3 meter, and so forth. Table 1.5 represents the prefixes commonly counted in chemistry. In using SI units and in working problems throughout this text, you will be comfortable using exponential notation. If you're unfamiliar with exponential notation and you want to review it, refer to Appendix A1. Although non-SI units are being phased out, some are still commonly used by scientists. Whenever the first encounter a non-SI unit in the text, the proper SI unit will also be given. Table 1.5. Selected prefixes used in the metric system. 10 to the negative 1 is deci. 10 to the negative 2, or 100th, is centi. 10 to the negative 3, or 1,000th, is milli. 10 to the negative 6, or millionth, is micro. 10 to the negative 9, or billionth, is nano. 10 to the negative 12, or quadrillionth, trillionth, is pico. And 10 to the negative 15, or quadrillionth, is femto. 10 to the third is kilo. 10 to the sixth, or millionth, or million, is mega. And 10 to the 9, or billion, is giga.